Hi guys, today we're going to solve a system of equations using Kramer's rule. So this is probably the last method of solving a system of equations that you'll learn, and possibly the easiest method once you get used to finding determinants. So here's our system. We've got three equations with three variables. We notice that our third equation is missing a z, so we're going to have to be very careful with that when we go ahead and convert it to a matrix. So our associated matrix is our coefficients of the x, the y, the z, and we usually write a vertical line after that, and then our number on the other side of the equal sign goes in the rightmost column. And z was missing from the third equation, so we have to write a 0 as a coefficient there. So our first step is to find D, which is our coefficient matrix. We just take the first three columns and ignore the fourth column of our constants, and we want to take the determinant of that 3 by 3 matrix. So I think the easiest way is just to multiply the diagonals instead of finding the determinant of a bunch of 2 by 2 matrices. So our positive diagonals will go down. So our first is 4 times negative 2 times 0. Our next is negative 5 times negative 5 times 2. And our last is 6 times negative 1 times 1 times negative 1. Our negative diagonals go up. That's our 2 times negative 2 times negative 6. That's minus that. Minus negative 1 times negative 5 times 4, and minus 0 times whatever. It doesn't matter. Once you get a 0 in a term, we don't really have to figure out what that is, because 0 times anything is 0. But I went ahead and wrote them out here for completeness. So our second term simplifies to 50, this term to plus 6, this term to negative 24 since we have 3 negatives, and this term to negative 20 since we have 3 negatives. So adding all those numbers together, we get 12 for D. That is our coefficient matrix, the determinant of that. dx, we replace the x column with our three numbers in our constant column from the original, which are negative 1, negative 12, 7. We go ahead and find the determinant of that, which is, again, we've got two terms that have zeros in them. Once we multiply all this out and add them together, we get dx is equal to 24. For the dy matrix, we replace the second column, or the y column, with the numbers on our constant column from the original. So in this case, the second column becomes negative 1, negative 12, 7. So multiplying all that out, it looks like we get negative 36 for dy. And finally, dz, the third column, or the z column, is replaced with the numbers in our constant column, which again, negative 1, negative 12, and 7. In this case, we're going to have 6 terms because our 0 got replaced and we no longer have a 0. So just be careful with that. Add them all up, we get 48. So now we're ready to solve for our variables. X is equal to dx over d, y is equal to dy over d, and z is equal to dz over d. In this case, we're going to get all integers or whole numbers for our answers, 2, negative 3, and 4. And we go ahead and write our solution as an ordered pair in parentheses, and some text like you to put brackets around it to indicate that it's a solution set, and your solution set contains this ordered triple. Alright, that's all for today.